So this is the very introductory lesson to chapter 11, which talks about area and perimeter of polygons and some other types of relationships. But this is areas of rectangles. And the first thing I want you to do, just based on your knowledge from middle school, answer true or false about these statements pertaining to four-sided figures and any figures in terms of polygons in general. So what do you think based on what you already know about polygons? So answer true or false now. Number one, if two figures have the same area, they must be congruent is false. When you're in middle school, you actually do units talking about this, but a very basic way to look at this is I can have a figure that has an area of 18 that has different lengths on the sides, like a 3 by 6 or a 9 by 2. Those have areas of 18, but those are not congruent because they don't have corresponding congruent sides. Number two, if two figures have the same perimeter, they must have the same area. Along the same lines, you can say false for that because you can come up with figures that do have the same perimeter, but they may not have the same area. So you can have, for example, let's say I had two rectangles whose total was 20 in terms of perimeter. So maybe I had 8, 8, 2, and 2, but I may have 6, 6, 4, and 4. Those have same perimeters, but they don't have the same areas. In fact, the first one has an area of 16, and the second one has an area of 24. Number three, if two figures are congruent, they must have the same area. That is true, because if they're congruent, they have corresponding congruent sides, and you can calculate the areas in a four-sided figure to just length times width for a rectangle or a square. So is every square a rectangle? We know that's true from our quadrilateral units. Is every rectangle a square? No. We also know that from our quadrilateral unit. The base of a rectangle can be any side of the rectangle. And that is true. And the reason they're bringing this up is because when you calculate the area of a rectangle, some people talk about it as length times width, but some people can also mention it as base times height. So A being base times height, it's irrelevant whether you call the bottom of this the base, or I could even rotate it, and maybe this B, if I rotate it, becomes the height instead. So it doesn't make a difference as long as you get multiplication. All right, some basic concepts here. So we have area and perimeter of rectangles and squares. So these are the two formulas that you're going to see on your formula sheet as well. I am going to provide you a copy of those. First one is a square. Perimeter is the sum of the four sides added up, or 4 times s, where s represents the length of the side. Additionally, because it is a square, you can calculate the area by taking one side and squaring it. Rectangles, if you label length with width rather than base and height, you can say perimeter is twice the length plus twice the width, or the area is length times width. So this is a postulate that is in your textbook. The area congruent postulate says if two figures are congruent, they're going to have the same area. So once again, it's just a postulate, something that we understand to be true, and you can demonstrate by showing congruencies, and then you would do the math calculation where the lengths would match up. It would be corresponding, and the bases would be corresponding, or the widths would be corresponding, depending on how you label it. All right, up at the top here. The area addition postulate. This is probably the most important thing from this particular section. So when you have an irregularly shaped figure, the area of a region is the sum of the areas of its non-overlapping parts. So you may have a shape that doesn't quite fit into the polygon definition that you're thinking about, but you could cut it into smaller pieces. So for example, with this particular shape, I could slice the picture so I'd have two rectangles. A 4 by 2 and a 5 by, what would be the length along the entire base? A 9. And then you could just add those together. Is there another way you could cut this? You could also slice it vertically instead. So you would have a 5 by 5 and a 4 by 7 and add those up. All sounds pretty familiar. There is one other thing that you can do. You could certainly complete the rectangle by extending out your sides. The only difference for something like this is you would take the area of the whole entire shape and you would subtract off the small area that you put in. So what would be the area of the entire large shape? So you can have a height of 7 and a length all the way across of 9. If you wanted to do it that way. So we'd have 9 here, and from here to here you'd have 7, and you get an area of 63. And then what would you subtract off? You'd subtract off this piece that you extended out. So the 63 minus 10. But whether you cut up the existing shape into smaller pieces or if you extend it to complete the polygon and then subtract off, you can do either way, you'll get 53 units squared. Okay, this last part ties into one of the true false questions that I was talking about. So in a rectangle, any side can be considered the base. And the altitude or the height can be defined as any segment perpendicular to the base. From a point on the opposite side, the length of the altitude will be the height. So in this particular picture, I could call this the base, and then I could label the outside as height if I wanted to. And the height is always perpendicular to the base. The reason they're showing this to you with the height inside of the picture is occasionally we're going to be calculating things where the physical height is at its highest point and perpendicular to the base inside of the shape rather than outside or on the side of it. Sometimes it occurs outside as well. And in the second picture, it is no different. If you consider that the base be one of the sides, then the height is the piece that's perpendicular to that. So it does not make a difference how you think of it, as long as you're consistent with the height corresponding as being perpendicular to the base. All right, some calculations here. So turn your paper to the side. It says find the missing value for each rectangle, so this gives you an opportunity to do some radical practice. So please do number 1, A and B, please. Do both. So for 1A, area is length times width, and I multiply together 3 square root 2 times square root 6. And that's 3 square root 12, but you need to reduce that square root 12. That's going to be rewritten as 2 square root 3. Multiplying your integers together gives you 6 square root 3. Alright, letter B, they are giving you the area, so you're going to be dividing by one of the sides to get the piece that's left over. We know area is length times width, so I can still set it up as the original equation, but I divide both sides by radical 3. But what do I have to do to finish it? Rationalize. Yeah, you have to rationalize the denominator, multiplying top and bottom by square root 3 over square root 3. So I have 24 square root 3 over 3. Then you're going to reduce that 24 over 3. That's going to become 8 square root 3. So letter C, for this particular polygon, I'm giving you the lengths in terms of binomials. So you have a length and a width of 2x plus 1 and x minus 6. They're not giving you an integer value for the total area, so you're going to write your answer with variables inside. So what am I going to do with the 2x plus 1 and the x minus 6? You're going to multiply together and FOIL them. So FOIL that out, see what you get. So your answer, 2x squared minus 11x minus 6. Number 2, the perimeter of the square is 8 square root 2. What is the area? To calculate the area, you need to know the lengths of the sides first. I know that the perimeter of the square is 4 times x, so I'm going to set that equal to the 8 square root of 2, so I can figure out what one side is. I'm going to divide both sides by 4. I'm going to get that the one side is 2 square root 2. I'm going to take that answer and substitute it in for s in the area calculation. So the area of the square is the side squared. So I'm going to take 2 square root 3 all squared. Now you can expand that out if you'd like. That's 2 square root 2. Sorry, I said square root 3 earlier. It is 2 square root 2. Times by 2 square root 2 again. And I'm going to use commutative property to change the order. So 2 times 2 times square root 2 times square root 2. And of course, here's my 2 times 2. And square root 2 times square root 2 is 2. So you're going to have 4 times 2, which is 8. Number 3, the area of a square is 40 centimeters squared. What's the perimeter? So once again, you have to calculate the side in order to calculate the perimeter. So the area squared is a side squared, so I'm going to set that equal to the area, which is 40. And I'm going to solve for a side by taking the square root. So go ahead and reduce that. The largest factor of 40 that's a perfect square is a 4. So it's square root 4 times square root 10, which is 2 square root 10. I'm going to use that answer to calculate the perimeter. So the perimeter of my square is going to be 4 times the 2 square root 10, which is 8 square root 10 centimeters. So number 4, here a rectangle is 84 inches squared. The length of the rectangle is 2 inches longer than twice the width. Find the width and the perimeter of the rectangle. So with these type of problems, you always want to build a picture. So my area is 84, and I take the shorter side and I label it with an X or a W, whatever your choice is. So if I know that the width is smaller, the length is 2 inches longer than twice the width. So 2 inches longer, which is plus 2 on the back, and then twice the width. So you want to label those with the expressions that are equivalent in terms of one variable, not two. Because ultimately we're going to have to solve this. So we're substituting in, if 84 equals 2W plus 2 times the W. And you'll notice that since the length of this rectangle is a binomial, I've parenthesized it. Because I'm going to have to distribute the width over it. So I multiply by W. So I have 84 equals, so 2W times W, which is 2W squared, and then plus 2W. Linear or quadratic? It's a quadratic, so we're going to set it equal to 0 by subtracting 84 from both sides. We are going to factor this, but I don't want to go directly to factoring into two binomials. I want to take out the greatest common factor first, which is a 2. So I have 0 equals 2, and then in parentheses W squared plus 2 plus 1W minus 42. And of course, I'm going to divide both sides by 2, so it's going to go away. So I don't have to worry about that. And of course, I'm just going to factor this. That's going to be W plus 7 and W minus 6. And so I have two solutions here, but you do need to make sure in the context of the problem that that negative works. In this case, I can't have a negative width. So I'm going to cross out that negative 7. So my width is 6, and then I'm going to evaluate my length by substituting my 6 in. So 2 times 6 plus my 2 is 12, which is going to be 14. And to finish this up, the perimeter, twice the length plus twice the width. And that gives me 40. So we have some tricks to do, so do not pack up yet. Number 5, find the area of the rectangle to the nearest tens. You are going to have to do a couple problems where they give you trig relationships. In this problem, they only give you the diameter, and they tell you that you have a 30-degree angle between the base and the diameter. So this is a 30, 60, 90 triangle, where the 15 is the hypotenuse. Keep in mind that the hypotenuse in a 30, 60, 90 is twice the shortest side. So what's the width here? Let's just take half of 15. So half of 15 is going to be, you can use 7.5 or 7/2. Then the longest side is the short side times square root 3. Now you can certainly use that 15/2 if you would like. So for this problem, so what I've done over here is showing you that 30, 60, 90 shortcut that you have to have memorized for the SOL as well. Showing that the shortest side you follow length 1, double it for the hypotenuse, and the third side is times square root 3. So I've got my width, and they ask you to calculate your area. Well, from the calculation up top here, we have the length. You can see in my work I've listed it as 15/2 rather than the 7.5. And then, of course, you're just multiplying these two together. And the 15/2 are both there. You're free to use a decimal here if you would prefer. So we have 225/4 square root 3. And sometimes in the book it'll give you a situation where they don't want an exact answer, they may ask you to round it to the nearest tenth. So that does happen a lot more frequently in this chapter than it did in sections past. Look at letter B. Now this is a 25-degree angle, so this is not a shortcut calculation. This is something you're going to have to use your calculator for. So in this problem, I know the height or the width of this, but I don't know the base or the length, so I'm going to have to use my trig functions on the calculator. Make sure you have it set to degree, because I did reset your calculators. To figure out the length, are you going to use sine, cosine, or tangent? So you're going to use tangent of 25 equals opposite over adjacent. So tangent of 25 is 22 over L, and then you would go ahead and cross multiply. So you have L tan 25 equals 22, and divide by tan 25 on both sides. So you can see if I have that there. And then to calculate that, now with this type of a problem, it is up to you. You can leave the length in an exact, or you could round it if you want to. It's probably safer to round it at the end, so that's why I've shown it just as a fraction. I'll leave that up to you though. They usually come out pretty similar. So the area on this one is 1,037.9 units squared. Now we did not finish number 6, so I'll use that one as the beginning of Wednesday's lesson.
How are you?